Hi everyone and welcome back to my channel. In this video I'm covering the topic of relationship between the roots and the coefficients of quadratic equations. Now some of you might be confused by that definition, right? All I'm simply doing is I'm covering alpha beta and we're going to use alpha and beta to find the equation of the quadratic, right? So I have two questions to do and a detailed solution. So please stay tuned for my questions and solutions. Thanks. So if you didn't know, there's a video that I did already on alpha beta. Now this video goes a little further. In the first one, I told you, well, there are two terms, alpha and beta, and alpha plus beta is derived from minus b on a. Also, alpha beta is derived from c on a. Now you might say, Miss, where does a, b, and c came from? Well, they came from the general form of a quadratic, right, from here. So in this particular question now, this is how it goes. It says if alpha and beta are roots of this equation, form a quadratic equation in x whose roots are these. So this is part A. So what I'm going to show you all is how we're going to use this general equation here now to get our answer. So what it says here, it says x squared minus the sum of the roots by x plus the product of the roots is equal to 0. So we're going to use this in the latter part. So let me look at the solution for part A now. In part A now, they are telling us that we need to use these roots to find our new equation, and we need to use this. However, before we could start even attempting to find these roots, we need to work out what is alpha plus beta and alpha beta for this equation here. So in this particular equation, I'll just write it here. I have an a of minus 2, a b of 3, and a c of 1. So therefore, alpha plus beta, following the formula from up here, is minus b on a, which will be minus 3 on minus 2, 3 on 2. Alpha beta then would also be c on e, which would be 1 on minus 2. So now I have my values for here. So I will stick these in and we will attempt to now look at this part of it. If my roots are alpha cubed beta and alpha beta cubed, I need to do two things. I need to find the sum of these roots and I need to find the product of these roots. So the sum of these roots just simply means I'm sticking in a plus sign in between these two values and I'm trying to simplify. Now I'm going to simplify these two terms into anything that would look like these two, right? Now the only thing I could really see is I could factorize. I could factorize alpha, beta, so I'll put alpha squared here and beta squared here. Now this is nice what I have here. I have alpha beta here, which I know is already minus a half, so that's great. However, alpha squared plus beta squared is a little more difficult to simplify. But in my previous video, I showed you all how alpha squared plus beta squared is really, and I'll write it here, alpha plus beta all squared minus 2 alpha beta. Now actually what you're seeing here is I have simplified this expression here into just alpha beta here and here, and an alpha plus beta. So now I could simply come and substitute these values. So alpha beta would be minus a half, alpha plus beta all squared would be 3 on 2 all squared minus 2 by minus a half. Now I simplify this, I will get 9 on 4 positive 1, and that works out to be minus a half by 13 on 4, and multiplying these two, I'll get minus 13 on 8. So this, everybody, is the sum of the two roots that I was given here, right? Now I need to find the product of these two roots. The product of the roots simply means I'm going to multiply these two values. So I'm going to write alpha cubed beta multiplied by alpha beta cubed. This ends up giving me alpha to the 4th power and beta to the 4th power, which is lovely because then I could just write alpha beta all to the 4th. And that's simply by substituting here, the minus a half, I will end up getting minus a half to the 4th power, which will end up being 1 on 16. So I could just take off my brackets. So that is my value for the product of the roots. Now I need to do the last piece, which is to substitute into the equation, right? Substituting into the equation now says it's x squared minus the sum of the roots x plus the product of the roots equal to 0. So I'm simply going to write x squared minus, what's my sum? This minus 13 on 8 x plus the product of the roots, and my product is 1 on 16. Now some people leave it like this, or some people simplify, right? Well, so for me I will write plus 13 on 8 plus 1 on 16, and I'll multiply the entire equation by 16. So I get 16 x squared plus 16 by this will be 2, 26x plus 1. And the reason why I multiply by 16 is because I'm looking at the denominators here, 8 and 16, right? And that will be the LCM. 16 will be the LCM. Okay, everybody, so this is the end of part A. Now to go about the same steps to find the solution for part B. Part B, I have been given two other roots. So again, I find the sum of these roots and then the product. So the sum will be alpha squared plus 1 on beta plus beta squared plus 1 on alpha. And simplifying this, I get alpha squared plus beta squared plus 1 on beta plus 1 on alpha. This works out to be alpha plus beta all squared minus 2 alpha beta. And this piece here, I could find the LCM, and I will get plus beta alpha, and beta into beta alpha will be alpha, alpha into alpha beta will be beta, and we multiply by 1, of course, and that's how I get that. So this is lovely. Now I could substitute my alpha plus beta for 3 on 2 here, and alpha beta for minus a half. Substitute, now I'll get 3 on 2 squared minus 2 by minus a half plus 3 on 2 all over minus a half. So simplifying here now, get 9 on 4 plus 1 plus 3 on 2 divided by minus a half would be multiplied by minus 2 over 1. Cancelling this, I'll get minus 3 here. So now this would be 13 on 4, this here works out to be 13 on 4 plus, minus 3 because of this minus here. So now simplifying this, get 1 on 4. So this, everybody, is the solution for the sum. Now let me find the solution for the product. Product now will be alpha squared plus 1 on beta by beta squared plus 1 on alpha. Expanded, now I'll get, I'll write it here, alpha squared beta squared plus alpha, because alpha squared by 1 on alpha is alpha, 1 on beta by beta squared is beta, and 1 on beta by 1 on alpha is 1 on alpha beta. Right, so this is nice. We'll do this, alpha plus beta plus 1 on alpha beta, and lovely. Substituting again, I get minus a half squared plus, this is alpha plus beta, 3 on 2 plus 1 on a half, minus a half. So this turns out to be a quarter plus 3 over 2, and this is 1 divided by minus a half, which is 1 multiplied by minus 2 on 1, which is minus 2. So this is minus 2 here. So now simplifying all of this, minus a quarter. So now I have a value for the product, and I have a value for the sum. So I'm just simply going to substitute into my equation up here. So that says x squared minus the sum of the roots is minus, the sum is minus a quarter x plus the product plus minus a quarter. So simplifying this, I get x squared, let me take this off because it makes it look like a negative, minus a quarter x minus a quarter. Multiplying by 4 now, just come over here to multiply by 4, 4x squared minus x minus 1. So that, everybody, is the solution for part B. Okay guys, so I hope you follow, I hope you understand all my steps, and I hope that you feel free to look at this again and again to make sure that you understand. Okay everyone, good luck with your advanced, and feel free to tune into my other videos to learn some more about other topics. Thanks guys.